follow up with a couple of things from the last lesson there on sales tax and tips and discounts. And we're going to cover a couple more things. One is called markups, because you'll see these on the IXL topics. And then a couple more sale price problems, because those are very common, and kind of combining some things together. All right. So first we'll talk about markup. So a markup is what a store does to increase the price of their items so that they can make money. So the store buys the items at normally what's called wholesale. Okay, so the store buys the items and then they turn around and they sell them to you, the consumer, which is called retail. Okay, and when they sell the prices, they have to increase the price that you pay so that they make their money. And that increase in the price is called a markup. And very often it is a percent of the original price. Okay, so the example here, so these work just like taxes or tips. It is a percent that is added on to the original price, and the original price in these problems is the price that the store pays for the item. That's also typically called the wholesale price. Okay, you won't see that word though. It'll just say what the store pays. So the store pays $56 for a GPS navigation system, okay, and they mark it up 25%. So the store is going to add some percentage at this 25% to get the selling price that you're going to pay. So that 25% is added on just like a tip or a sales tax. So there's two methods again. You can calculate the markup. That's the extra money that they're going to charge, right? Which is 25% of the store price, 0.25 times 56. Or if you wanted to, you could use the percent proportion for all of these problems. Okay, so again, we'll put the percent proportion down here again for this problem, which is an alternate method for you to use, which is 25 over 100, right? The percent over 100 equals, and the other side is going to be the part X, which we don't know, the markup, divided by the original price. Okay, so the percent proportion, again, just like always, if you don't like the converting decimals like they do up here, right? Convert 25% to a decimal, 0.25. You can always use the percent proportion. You'll get this same $14 answer. So that $14 is the markup, which then is added to the original price that the store pays, and the selling price then will be $70. Just like with taxes and tips, you can do this in one step. This is the fastest way to do it. 100% plus 25% means multiplying the original store price by 1.25. And that will also give you the selling price of $70. Don't forget to put dollar signs on all these. They are all money problems. So you will always have a dollar sign in your answer. Okay? Just to give you some thoughts here, this is how much stores mark up in different businesses, right? Like a grocery store markup is typically around 15%. At a restaurant, the markup is about 60%. So what the restaurant pays for the food that they serve, they mark that price up 60%. Beverages like sodas and things like that can be marked up 500%, 5 times what the store pays. Okay. Pharmaceuticals could be marked up 1,000%. That's a bit of contention for some people. Okay, anyway, so different businesses mark up. They decide how much to mark up their prices to figure out how they're going to make their money, how the store makes its money. All right, so here's a got it on that one. The store pays $150 for a portable basketball backboard, and they mark it up 40%. Markup means the price is going to increase by 40%. Excuse me. What is the selling price? So the only method that I've shown here is going to be the one-step method. Okay, let me go back over here and grab this. Okay, the percent proportion. We could do the percent proportion for this problem, except instead of 25% and $56 for the original price, it's going to be 40% over 100. And the original price, the whole, is $150. Okay, so this would be the proportion you could solve to find the markup. Okay, or you can just find the markup by doing 0.25 times 150. I'm sorry, 0.40 times 150, right? Which many of you can do this in your head. This is one of those, you could use the 10% rule, right? And do this one mentally. 15 times 4, $60. Okay. That's 40%. Or, so this gives you the markup. If you solve this proportion, you'll get 60. If you do it this way, you get 60. That's the markup, how much you're going to increase the price. Okay. So then you add that to the $150. Or you can do it all in one step. 1.4, 100% plus 40% as a decimal times 150, and you get your selling price of $210. Okay, so that's how to do markup problems. It's the same as tax or tip, a percent that is added on. All right, now let's look at a couple more discount problems, because some of these now can be multiple things happening, right? Oftentimes you pay sales tax and something is on sale. So that's this example. I might have gone through this with one class, but I didn't do it in all of them. So page 161, example 2. Boogie board has a regular price of $69. It's on sale for 35% off, 35% discount. What is the sale price with 7% tax? So in these problems, you always take the sale price first. First, you find the sale price, then do tax on the sale price. Okay, you don't do the tax on the original price because that's not what you're paying for it, and the tax is based on what you're actually paying. Okay, so you find the sale price first, then you do your tax on using the sale price as the whole. So first, find the amount of the discount. That's the sale price. Okay, so here they use the 0.35 times 69, which is $24.15, and that gives you subtract that from the original price, giving you a sale price of $44.85. That's the sale price. Okay. You can also do this using method 2. 35% off means you're paying 65%. So you can just do 0.65 times 69 to get $44.85. That is the sale price. Okay. Then the percent of tax is applied on the sale price. So now $44.85 is your new whole, and 0.07 for 7% sales tax gives you a tax of $3.14, which you then add on to the sale price to get your final price of $47.99. You can also go right to that by the one-step method, multiplying $44.85, the sale price, by 1.07, 100% plus the 7% tax. And again, you could do both of these using the percent proportion, which I'm not going to add on here, okay? So in these problems where you have something on sale and then you still have to pay tax, you find the sale price first, and then the tax is based on the sale price. So that's this problem right here. So I suggest that you pause the video and you work this problem out, okay? Or if I do it as an ed puzzle, I'll just give you the question, right? So what is the discount? What is the sale price? What is the tax? What is the final price you are going to pay? There's 4 different numbers that you need for this problem. Okay. All right. So method 1, first we're going to find the sale price, which means we find the discount, 25% off. 25% off of $15.50 is $3.88, rounded to the nearest cent. Okay. We subtract that then from the original price to get a sale price of $11.62. This is the sale price. We label all these numbers here. Okay. Sale price, $3.98 is the discount. That's the amount that is taken off. Okay. The next thing we're going to calculate then is this 6.5% tax that's added on. So that's 0.065 times 1162. The sale price is what you pay the tax on. So this is the tax, right? And that means then this is added to the sale price because tax is added on. And so the final price, okay, this is the final price, what you have to pay, the sale price plus the tax, okay? You cannot do this all in one step, right? You can't add subtract the 25% and add the 6.5% at the same time, okay? Because these percents work on different numbers because the tax is only on the sale price. So you can find the sale price using the one-step method. 25% discount means you're paying 75%. That's 1163. Excuse me. A little bit different because of rounding, okay, but only off by a penny. And then, so 1163 is the sale price, just like we got 1162 over here. And then to find the tax or the final price by adding the tax on, you multiply this by 1.065. Okay, 1.065 times 11.63 gives me $12.39. Off by a penny, that can happen because of rounding. Okay, it just depends on how you do the problem. So either one of those answers would be correct. $12.38 is what the book gets because they like method one. They like doing all these in separate steps. Okay, me personally, I like doing them in the quicker one step, but really you do need to be able to do this because if I asked you what the discount was or what the tax is, then you have to be able to do it by this method. Okay, and again, you could use the proportion if you wanted to. Set up the proportion for this first one. 25 over 100 equals X over 1550, and you'll get $3.88. And on the bottom one, 6.5 over 100 equals X over 1162, and you'll get the 76-cent tax. All right, here's another example now, or maybe comparing some things, which is pretty common. Okay, two stores are having sales. One has a pair of sneakers on sale for 40% off of $50, and another place has the same brand of sneakers for 30% off of $40. Well, which store has the better price? This is a real world problem that you can use all of the time to save money. If you don't understand percents, then you lose money by not making the best decisions on finding things that are cheaper. So Clothes R Us, 60% is 40% off of $50. So they're doing it in the one-step method here. So they're saying, well, if you pay 40% off, then you're paying 60%. 60% of $50 is $30, which is what it's on sale for at Clothes R Us. You could also, if you had to, do 0.6 times 50 to get the discount. Sorry, 0.4 times 50, the 40% discount. 0.40 times 50, that equals $2, right? $20, right? And then you take that off of the 50. 50 minus 20 equals $30. Okay, that's the price for Clothes R Us in the two-step method. Ratcliffe's has 30% off of $40. Okay, so 30% off means you're paying 70%. So the book, again, is using the quickest method here, which is not the easiest to understand. Instead, you might want to do 30% of $40. That equals $12. Okay. And so so 40 minus 12 then is $28. Okay, that's the two-step method. Two-step method for getting Ratcliffe's price. Okay. So turns out that Ratcliffe's is going to be a better buy. Their sale percentage is not as high, but the price is lower, and Ratcliffe's turns out to be cheaper. Okay. Now it asks the follow-up here. If the sale at Clothes R Us was 50% off, which would be the better buy? So we already know Ratcliffe's is $28, okay, because they didn't change. Okay, so Ratcliffe is $28. What is the Clothes R Us price if it's 50% off? Now, this is one you should be able to do in your head, right? If it's 50% off of $50, this one you should do in your head. No math required. No calculation required. What's half of $50? That's right. It's $25. So now, which one is cheaper? Clothes R Us is cheaper. $25 instead of $28. So answer the question. Clothes R Us is cheaper. $25 is less than $28. This would be the justification, right? Why you decide that Clothes R Us is cheaper. All right, so there's some guided practice problems here, which I am going to assign here on a class kick. So there's going to be problems on the one problem here on page 162 on a sale price. And then these 4 problems on page 154. These will all be done on a class kick for you to practice and check your answers. All right. So we've covered tax, tip, markup. Those are 3% that add on to the price of something. And then we've talked about discounts, which is the sale price. That's a percent that is subtracted off of the original price. All great real world stuff that everybody should understand.